Hi, I am Jenga Niharika. Today my topic is implementing queues using arrays. Firstly, we have to know that what is queue. A queue is an ordered collection of items where the addition of new items happen at one end, called the rear, and the removal of existing items occur at the another end, commonly called the front. Working of queue. Queue is a linear data structure which operates in, first out or last in, last out. Queue operations. There are 5 standard queue operations. We also have 2 more, peak, change, but those are not very relevant over here. We're gonna be implementing these 5 operations. Firstly, NQ. Elements are added from one end. DQ. Elements are removed from one end. Is full. Check if queue is full. Is empty. Check if queue is empty. Count. Gets count of total items in queue. Count shows that how many values are actually there in the queue. If size equals to 7, let 5 and 6 in the queue, then the currently count of the queue is 2. Depending upon the NQ and DQ operations, this count value changes, but the size of the queue does not change. Now let's see different operations. Before we start with different operations, we have some particular initializations. When we are going to implement queue in the next part, that in the program for implementing queues using arrays, in this first thing we have to do is int arr is of 7, which means that our array size is 7 and it is a integer type array. Since we know that elements are added from one end, that is rear end, and they are removed from another end, we need to have two different individual variables. In stack, we only have one end, top, but in queues, we see that at one end elements are added and removed from another end. Initially, what we do is initializing the rear and front values to -1. Now let's see individual operations. The first operation is empty. Here we simply check if the front value is equal to -1 and rear value is equal to -1, because when initializing happens, front and rear set to be -1, which means nothing is there in queue. This indicates our queue is empty. Let's see another operation, is full. Here what we check for is if the rear is equal to size of array -1, return true. Let's see the NQ operation. It says that first we have to check if the queue is full or not. Obviously, we cannot add more values if the queue is entirely full. So the first thing we have to do is to check whether the queue is full or not. If the queue is full, we have to return from here entire NQ operation. If this condition is not true, we need to check for one more condition. If the queue is empty or not, because if queue is empty, then the rear and front is equals to 0. As the same, we have to check for third condition. If the second condition is false, then we have to check for the third condition. If there is some already existing value, we have to just do rear plus plus. And next, let's see the last operation, DQ. Now in DQ, first we have to check if the queue is empty or not. If queue is empty, we cannot perform DQ operation. If the Q is not empty, then go to next condition. If front is equal to rare, then front equal to rare equals to -1. If this condition is also not possible, then go to the third condition, that is front plus plus. Some applications of Q. Q is used when things possesses first in first out order, like CPU scheduling, call centers, printer management, traffic systems, task scheduling, job scheduling. These are some of the applications of Q. Thank you for listening.